So maybe I should start back. I'm Estelle. I'm a research scientist at the Perimeter Institute, mostly working at the Quantum Intelligence Lab at the Perimeter Institute. I'm also an adjunct professor, assistant professor at the University of Waterloo. And I'm a co-founder and CTO of yiyaniQ, which is a quantum/AI tech startup. I'll tell you more about that. But first, a little bit about my origins. Can you see my slides moving?
Yes, we can see it.
Okay, nice. So I'm from Cameroon. It's this country in the central part of Africa, bounded by Nigeria, Chad, Central Africa, Congo, Brazzaville, Gabon, and Guinea Equatorial. So this is where I was born. That's where I live. I did my bachelor there in physics and computer science, and at this University of Waterloo. Very nice little town in the Anglophone part of Cameroon, close to the biggest mountain of Cameroon, Mount Cameroon. So I did my bachelor there in physics and computer science. Then I did my master there in physics. At the time, I was working on mathematical models to basically represent biological neural networks. So I was kind of already interested in neural nets at the time, but from a biological perspective. And after my master degree, I got a scholarship and I moved north to Italy. I went to ICTP, International Center for Theoretical Physics, in Trieste, in Italy. It was created by Abdus Salam, who was a Nobel Prize winner. And there I did a postgraduate diploma in condensed matter physics. And after my postgraduate diploma, I joined CISA, which is a PhD school. I had a joint PhD between ICTP and CISA. And I did a PhD in statistical physics. And at the time, I was focused on basically using quantum Monte Carlo methods to simulate quantum annealers, what people nowadays call quantum-inspired methods. And towards the end of my PhD, I started being interested in machine learning stuff, especially artificial neural networks. And I applied to PI and I moved farther from Africa. I came to Canada, where I am now in Waterloo. At the Perimeter Institute at the time, I joined the Quantum Intelligence Lab. I was a postdoc for 3 years, and now I'm a research scientist here. So I started working more also in the AI field. That's how basically I augmented my quantum-inspired research with artificial neural networks. And it's a field that we kind of call now quantum intelligence. So that's a little bit of the story about my journey at the high level. So the presentation of this presentation outline of this talk, I'm going to talk a little bit more about my PhD research and how during my PhD I became aware of the industry world. I think for you guys it's probably different, especially for you guys doing PhD now, because now when we talk about quantum computing, we see a lot of actors in the industry. At the time when I did my PhD, it wasn't the case. Like we not go to conferences and see IBM or Google and other stuff. It was really still very much academia. But I'll tell you a little bit about how I became aware of the industry world. And then with my postdoc, how I rediscovered with my collaborators a new route to optimization that led to the birth of my startup, yiyaniQ. And the last part will tell you about what your place in the quantum computing value chain could be. All right. So let's start with my PhD research. So this is the first page of my PhD, right? I did it a long time ago, 5 years ago. That was a long time. And the title was Simulating Quantum Annealing via Projective Quantum Monte Carlo method. All right, so what is quantum annealing for maybe those who are not familiar with that? So quantum annealing is simply a concept or a method that people use to solve optimization problem using quantum resources. And typically as physicists, we like to view optimization problem as this kind of crazy energy landscape that has a lot of local minima and a lot of saddle points. And solving the optimization problem is actually finding the deepest value in that minima. And if you cannot find the deepest value, because typically it's very hard, finding a near optimal value is always good. But the way you do it with quantum annealing is designing some sort of quantum fluctuation to search the landscape. So there has been quantum fluctuation, typically quantum tunneling to search the landscape, but before quantum tunneling, people were using thermal annealing, that is thermally activated process to search the landscape. Which one is better, or even now, I can even say which one is better, because at the time we were like, which one was better, but even now it's not completely clear whether thermally activated processes or quantum activated processes are better algorithms in searching of the landscape. But early results actually on experiments on this other ferromagnet show that when you try to solve an optimization problem or to find the ground state of a ferromagnet using a quantum path by doing quantum annealing, compared to doing the blue path with thermal annealing, actually the quantum path was more efficient than the thermal activated path. So you see, this is very old research in 1999. And so this basically prompted people at the time to design this kind of quantum annealing process in a programmable manner. And that was the birth of the first quantum annealing device, which I think a lot of folks know now, D-Wave. And nowadays we have a lot of different quantum platforms that have an annealing paradigm, like neutral atom-based quantum startups. And in Europe, we have a company like Pascal. In US, we have, what is that company, Quera, right? That use with biatoms to basically stimulate quantum annealing. So that's kind of the story of the quantum annealing part. But then during my PhD, I was not interested actually in running the quantum device. So I was like, look, at the time, D-Wave cost $10 million. We didn't have that much money. I was a PhD student, you know. So I was trying to think about how can I use my laptop to actually simulate this behavior, and was through the use of quantum Monte Carlo methods. All right. So what is a quantum Monte Carlo method? So quantum Monte Carlo method simply leverages this quantum classical mapping that exists between a quantum system in D dimension that could be mapped into a classical system in D+1 dimension. And once you map the classical system in the D+1 dimension, you can now simulate it using just normal Monte Carlo methods. And then you basically change your parameter to basically mimic the annealing dynamics, all right? So this kind of concept that we use to actually mimic the dynamics or to simulate the dynamics of quantum annealer using like just traditional high performance computing architecture, and then you can scale it up on multiple CPUs, nowadays multiple GPUs. All right. So at the time as well, I became aware that, okay, we are not just trying to solve fine ground set of Isinglass problem, right? And this came from the fact that for me, and that was kind of one of the point of transition from just thinking about pure condensed matter research to actually thinking about real world problem. And the fact is that optimization problems are ubiquitous, not only in science, but also in life, real world life, right? You can map the so-called traveling salesman problem. That is a problem of finding the shortest path going through a different number of cities once. And basically you want to minimize the shortest path that traveler has. That's an NP-complete problem, and that can be mapped as an optimization problem. The problem of basically finding, what is the minimum configuration of atom interacting via some sort of potential? So that's kind of a quantum problem that you can, this is also an optimization problem, right? The problem of optimizing a deep neural network, right? That's an optimization problem. Protein folding, the problem of finding the native state of a protein out of many possible configurations or conformations, that's an optimization problem. And what I'm currently focusing on, the problem of finding the optimal way of allocating assets that you have in your portfolio. So the common denominator of this problem is that you can map it as an optimization problem. You can have a representation as a quantum Isinglass or a classical Isinglass, right? And then you can solve it using quantum annealing or even using digital quantum computations, right? And using methods like QRA, for example. So for me, that was kind of where I saw the opportunity of going from something that is purely statistical physics, condensed matter, to actually, especially this part, something that is commercializable, right? And how I could use methods that I actually designed during my PhD to solve a real world problem, right? So the lesson that I learned in my PhD is that not only quantum Monte Carlo methods could be used to benchmark with quantum devices, but because at the time also there was a huge debate, is D-Wave really quantum, is it not quantum? And then typically the comparison was using quantum Monte Carlo methods. Nowadays people use a lot of tensor networks to check quantumness or other methods to check our quantum devices. But that debate is no longer really like in place. The other thing that I also realized is that these devices that people were building at the time, which are being built right nowadays, and really a lot of them are accessible through the cloud, is that they are trying to solve real-world problems. So I saw how my own research could also be used, not just only to probe quantum matter, but also to solve real problems, right? And now, the more I was attending conferences, I started to see that, I mean, the profile of people attending that were not just people in academia, they were also people in industry, the people in government. And so that kind of opened my mind at the time to see that the quantum computing space was going beyond the lab, right? Which should be pretty much different for you today. So that was my PhD, and then I moved to the postdoc, and the postdoc basically we designed a new algorithm that was not just based on exploring a configurational space to find the deepest minimum, but actually exploring a parameter space variationally. So we added a variational part on quantum annealing, and that additional part was due to the fact that now we're using neural networks or deep neural networks to mimic the behavior of quantum annealing, all right? And then we had this very nice paper published in Nature Machine Intelligence, and we showed that the variational emulation of quantum annealing would actually outperform in some cases the coherent quantum annealing dynamics and the simulation of quantum annealing using Monte Carlo methods that rely on Markov chains, and Markov chains, when you have a glassy system, can become crazy, whereas if you use sampling with an autoregressive neural network, we showed that it was better than just doing Markov chain sampling, all right? And that paper led actually to a patent. At the time, I had an affiliation with Vector Institute, so they own the IP. And the lesson that I learned with my postdoc was that the combination of quantum plus AI in this new field called quantum intelligence can be a powerful tool for optimization, right? And then I figured out that patenting is not enough. So filing the patent is not enough. What do you do after you file the patent? And maybe I'll stop here and comment on the fact that, so before, as physicists, we really didn't think about the patent. In fact, I didn't even know what is intellectual property. What do you do with that thing? I didn't even know that I had signed an IP policy with Vector. Usually you just sign your contract, you don't pay. You just check your salary. How much are they paying me? They pay me that. Okay, maybe I'm fine with that. How many years do I have on my contract? Fine. Okay. And then you don't care about the rest. You should care especially about intellectual property. Who owns the IP at the university where you're staying, right? So at the time, I became aware of IP, patenting, and stuff like that. And yeah, I figured out that not only it's very expensive, but then you need to figure out what to do after that. So at the time, Vector told us that either you license it, so you find companies that can commercialize it, or you commercialize it yourself. So commercializing it for me meant that I needed to create a startup. Right? And the second thing is that commercializing was not enough. So I saw that I had kind of a hammer. That is, I have this very nice algorithm that in principle can solve very well any kind of optimization problem, but as I showed in my previous slide, there are so many optimization problems, right? So I really needed to focus on what in the business world they call vertical, which is just focus on a specific field, right? And for me, we decided later on to focus on finance. And so I came to know about this chart that, okay, I have the tech, and I have the vertical, so I can show that my solution is feasible. But at the end of the day, if your solution is not valuable to a user, right? And then if it's not usable, you will not reach that green spot. That means that you can actually you can provide a business value to a customer, right? And I had to start changing a little bit the way I think as a physicist, because as a physicist, when you think that, oh, I'm writing this way, I've designed this really neat method that can reduce the accuracy by 1 order of magnitude, 2 order of magnitude, if it does not translate to a dollar value, people in the business world, they don't care at all. So I needed to start thinking a little bit more business-like. How can I actually bring value? How can I find this green intersection of tech, vertical, and user, right? So I got to know through a lot of talking with Perimeter, a lot of talking with Vector. So I got into 2 incubators. One is Creative Detection Lab, is in Toronto. The other one is also Entrepreneur Fest, is in Toronto. And there I met my co-founder, and I decided to found my company startup, yiyaniQ. So yiyaniQ, it comes actually from the name. A lot of people have a hard time to pronounce the name of the company, but I can tell you a little bit where it's coming from. So I'm from Cameroon, as I told you. I'm from a tribe called Bassa. And then Yiyani is kind of a breakup of 2 words. Yi means intelligence, and Yani means tomorrow. So both of them means the intelligence of tomorrow, and Q is for quantum. So that's how come the name is that, quantum intelligence for tomorrow. So we believe that quantum techniques plus AI better intelligence afterwards. And then we decided to apply it in finance. Benham is the CEO, I'm the CTO. And Benham had worked in the financial industry. He has a PhD in actually in condensed matter from the University of Waterloo. And after his PhD, he was like, I'm out of academia. He went to work for Scotiabank for 7.5 years. And then he got fed up with finance, I guess. And then he decided to start something new. And we met at Creative Destruction Lab. And then we decided to create yiyaniQ. So basically what we are doing is we are trying to solve optimization for in finance using quantum-inspired algorithm plus generative AI. All right, and then we leverage kind of the Waterloo / Toronto Quantum AI Ecosystem, PI, University of Waterloo, and then the Vector Institute. So maybe now I can tell you a little bit about the fact that also my trajectory is not like typical. It's not singular. Like IQC, which is the Institute for Quantum Computing, is kind of a sister institution here in Waterloo. For quantum, they are really focused more on the hardware side of things. And then in this website, they say that there are 17 startups that are spun out of quantum research, out of IQC, from quantum research at theories, experimental and stuff like that. So this is just to tell you that this is a new trend where researchers are saying, my research could be commercialized, but and they are starting to think a little bit more about this entrepreneurship pathway. So you should think about that. And you should think about where's your place in the quantum value chain. So quantum is really big. It's really like a very big word, right? There are different, usually you hear about quantum computing company like Amazon that is trying to be what they call a full stack quantum computing company, where they build hardware, they build basically software that runs the hardware, and then they develop quantum algorithms that use the quantum hardware plus quantum inspired to solve real world problems, and then they do quantum networking, and then they do quantum cryptography. So they do kind of everything that concerns quantum. And inside that stack, so here I kind of presented different parts of the stack, the part where you have the device, the part where you have the controls that actually run the device, because you need to cool down stuff, you need to have control electronics and stuff like that, right? The part where you actually need to build and put together, the quantum computer, the part that, okay, maybe you need to know how to put it on the cloud, because nowadays, it depends on the business model. Some quantum computing companies, their business model is basically to sell the quantum computer and come and install it on your premises. Other quantum computing companies, they basically offer the cloud. Other build software, compilers, and other build application like mine. And other people are focused on education, consulting. Some folks even have quantum games and stuff like that. So you need to think about your own expertise. Are you more in the quantum info side? Are you more from the computational science, approach to quantum computing? Are you more on physics approach to quantum computing? Are you more of like a quantum chemistry approach to quantum computing? Are you more, somebody is into education? Are you more into somebody who has actually kind of a hardware expertise to actually build an actual quantum computer? So depending on your expertise, you will know where you fit in the stack. All right. And my last slide will be about some tips to get into the field if you are not yet into the field. So the first will be educate yourself. Try to read white papers, blog posts, reports. There are a lot nowadays out there. McKinsey try to have like reports every other year or something like that. Zapata also has pretty nice resources on the website. Try to attend quantum business conferences if you can. There's this quantum tech conference, Q2B. I'm attending next week in Silicon Valley. There's Inside Quantum Tech Canada and many other quantum business conferences on top of already the quantum conferences you're probably attending in science, right? Check non-diluted funding in case you're interested in entrepreneurship. You can use MyTax. MyTax is a pretty neat way for you to get involved with, if you're in Canada. For the guys in Chicago, for example, there's a huge Chicago quantum initiative going on. So in Chicago, they are also trying to really build the whole ecosystem, bringing together like the science and also the entrepreneurship part of it. I think they probably also have an incubator and accelerator or something. In Chicago, in Europe, it's also becoming big in quantum. Like Munich is trying to build this quantum ecosystem. Almost all countries now in Europe, it's becoming kind of a national strategy to do quantum. But in Canada, we have this MyTax, which helps students basically do internships in startups or in industry while doing a PhD or while doing a master's. Right, there are grants and say quantum trade and stuff like that. If you're interested in commercialization, talk to your university/institute commercialization office. They will tell you about intellectual property. They will tell you about how to build a startup and stuff related to that. Check incubators, CDL, Entrepreneur First, Next AI, Founder Institute, and many others. Look for startup hubs. Here in Waterloo, you have Community Tech. In Toronto, we have Mars. In Quebec, there's District Q, Quebec Quantic. In Calgary, there's Quantum City. There's probably something BC. And if you want to, we are really serious about building a company. Raise family and friend rounds and be ready to bootstrap. We've been bootstrapping for almost 2 years now, so it's not easy. And then when you're already raised angel/venture capital funds, and you probably need a POC or the MVP. And yeah, go build if it's your route. If it's not your route to do entrepreneurship, then get involved in some of those industries. Right? Now, nowadays, there are so many industries like IBM, Xanadu, Zapata, One Qubit, Pascal, yiyaniQ. I mean, Cambridge Quantum, there are so many. Right? You don't need to just, or you can stay in academia if you want. Right? Nowadays, there are also a lot of positions opening up in the quantum space, so you just have to decide for yourself what suits you best. Maybe the last comment I will make here is that when I was doing my PhD, it was more of a traditional path. So the moment you get out of academia, that's it. You are not likely to come back in academia. It's almost the death sentence of your academic career. But nowadays, we are seeing colleagues that do the look back, right? I have colleagues that went after their postdoc, for example, to work for IBM for a number of years. And when they work there, they do typically only research. And after IBM, they went back having a faculty position at the university. So basically the mindset, the old traditional kind of mindset is really changing. And people are becoming aware that you can still do very much valuable research while being at a company. So don't think that if you quit academia totally, that's it. You will not become a professor. So yeah, that's the end of my presentation. I'll be happy to take any questions that you have.
Yeah, thank you so much, Estelle. It was really an interesting one. And I would say your story is really inspiring. I really don't know how you did it, but it's good to learn that you were first off like coming out of Cameroon and then getting a scholarship to CSER and then to Canada, and how you really kind of pivoted to industry is really striking because a lot of us, just as you said, we really don't have that industry background or that mindset, but seeing you go out of your way to develop and build those skills that placed you at the right level to leverage, your experiences so far and then start up a company. I think that's really awesome. And maybe I would start with some, or maybe I'll open the section, the question and answer section with my own question. So first off, I would say I wanted to find out actually with startup, maybe, so where are you at now in your startup company? So what stage are you now commercializing, or are you guys still on R&D? And then the next question would be, how do you guys actually raise fund? How do you source for fund? I think that's also like a really important, parameter, I guess.
Sure. So maybe I tell you a little bit more in detail the startup journey. At the time when we started, we were really focusing on how can we use quantum hardware to solve problems in finance. So at the time when we got into CDL, what we're looking at is derivative pricing. You don't need to know about that. It's kind of a very hard problem to solve in finance. And we wanted to use D-Wave from a computer. And so we actually did experiment a lot with D-Wave, didn't work for so many reasons. So we pivoted, which is very typical to startups. And we changed the problem we were looking at, and we started looking at portfolio optimization, and we also changed the method we're looking at. So instead of using quantum hardware, because when we kind of explore at the time the current state of noisy, intermediate scale quantum devices, we felt like they were too limited to solve real world problems when you started adding real world constraints, right? You have problems with connectivity, you have problems with the noise in the devices, you have problems with scalability, and so on and so forth. So we decided to use quantum-inspired methods, which are very much more flexible, and also with neural nets, which you literally can encode whatever you want, and you can scale things up on multiple GPUs. So the stage where we are right now is using those quantum-inspired methods with AI. We've developed an MVP, a minimum viable product, that is already accessible right now to our, so we do what is called B2B. So we are a business to business. We are not business to customer. So our potential clients are financial institutions, right? Banks, pension funds, investment funds, right? And so we are currently talking to a lot of them and demoing before them, and we are hoping to have a partner to help us iterate more on the product, and potentially that partner will become a client. And when we have a client, then we can go to raise funds. We've talked also with a lot of angel investors. For those who don't know, angel investors are high net worth people who invest in startups. All right, sometimes there is a single person, sometimes it's a group of a network of angel investors that come together to invest in a startup. And usually they tend to invest in very early stage startups. But for them, from our kind of interaction with them, you need to have either a proof of concept or MVP to be able to raise funds, so which we didn't have at the time. Venture capital is a little bit higher up, and they take a huge chunk of your company, so you need to be careful when you already go to those venture capital funds. So right now we are not raising. We are trying to basically get this first partner, right? So how have we been sustaining ourselves? So I was very privileged to be, I'm still a researcher at the Perimeter Institute, so my salary still comes from Perimeter. So now I have two caskets. I like calling myself an academic entrepreneur, right? In the sense that I still do research, I still hire PhD students, hopefully soon I hire a postdoc. So I am still very much active in research, reading papers, attending conferences, organizing conferences. But I'm very, very much strategic in the way I do research, because at the same time, I am doing commercialization. So I focus on research that can be commercialized in my startup, right? This is how I'm able to do both. So, and my co-founder, I have quit Scotiabank, otherwise I would have been conflict of interest. So he has been bootstrapping. So we've been using our own fund basically to build a company. We've been helped a lot with our partner institute, both Vector and Perimeter Institute. Perimeter has helped us a lot to get students. They have paid their salaries, and we've been able to work with them. If we leverage my tax, planning to leverage my tax. And part of the PhD students that I will give them a possibility, if they want, to work on project related to my startup, so that they can have both academia/industry experience, right? So that's more or less how we've been navigating the landscape. But at some point, we really need to raise funds. So we are counting on the fact that once we get that partner, because they keep asking you, you need traction, and traction for investors is you having a client who is really using your product. So that's kind of the approach that we are having. I think that's your first question. You had the second one?
Yeah, you actually answered both questions.
Okay.
Saxophone and and the face. Yeah.
Okay,
So yeah, thank you so much. We are now on to Q&A. I see hands up, and I think we have questions on the chat first. So you could use the chat or use your hands up. So let's start with the questions on the chat because they came earlier. So one person said, how can they collaborate with you? And the other one said, yeah. Yeah.
How you can collaborate with you, me? I don't have a lot of bandwidth, unfortunately. So now I'm really denying collaboration because I don't have a lot of bandwidth, unfortunately. Currently, we are only two in the startup. We have someone, a financial person who is working as kind of a consultant. So it's very, very hard for me to accept collaboration right now. It's extremely hard. Hopefully, when we raise funds and then we have more money, then I can accept more collaboration. I already have academic collaboration that I have a hard time to keep up with. So sorry for now, maybe in the future. Now, the second question is, how many atoms did you consider in the optimization? Okay, so that's a good question. So one thing I didn't mention is, so when people talk about quantum computing, typically they talk about qubits. All right. Now, qubits could be represented in many different ways, right? You could use atoms, you could use flux qubits, you could use photons, you could use ions. So there are many different ways. It's not just atoms. Plus, my own optimization, I don't use quantum hardware, right? I just do simulation of quantum hardware, and typically I think about them as spins, like magnetization of the spins. I don't know whether that kind of answers your question. And the typical scale of the system. So in our papers, we went from hundreds of spins to thousands of spins, right? So I don't know whether that answers the question about optimization.
I think it, yeah, I think it did. Yeah, if it doesn't, please maybe a follow-up question. So let's go to Alex. Alex, please ask. Yeah, let's hear your question.
Oh, yes, thanks. I want to say also thank you for setting this webinar, and thanks to Estelle for this great, inspiring story. I do have some curiosity, like how long did you take from, I mean, first, did you face some challenging for putting in place yiyaniQ? What are some of these challenges, if you can share maybe one or two challenges, if you face some challenges? And the second question, how long did it take you from the idea to, they to put in place this startup? And are you already at the go build? I don't know, how long did it take you from the start to the go build? I don't know if you get my questions. Thanks.
To the what? To the what? I didn't get that point.
The go build, like the tips you share with us at the last slide.
Oh yeah, I'm a very peaceful. I guess I'm in the path of building for sure. Yeah, so challenges I faced. So the first challenge I faced was to figure out which name to use. I was extremely confused when we had the patent on where to apply it. At the time, I was checking out a lot of stuff like nurse scheduling problem, which is a problem of assigning nurses in a very big hospital, assigning their shifts. That's an NP hard problem, right? I was also thinking about electrical vehicle battery charging, which, I mean, how to optimize the charging time is also an optimization problem. I was thinking about chip design, which was kind of the original way people develop the simulated annealing algorithm, which is a problem of the optimal way of placing basically. Hey, moment. So the optimal way. Sorry, I have my friend coming in the office. Yeah, so the optimal way of placing transistor on a chip. So that's another very hard optimization problem. So there were many different kinds of optimization problems one could solve, plus the portfolio optimization problem. And one thing that I noticed is actually you need to have domain knowledge to be able to formulate that problem. So let me maybe come here. You need domain knowledge to be able to formulate that problem as an isinglass, which is actually mimicking what is happening in the real world. So I really needed to have somebody in finance with domain knowledge in finance to be able to formulate that. So that was the first problem that I had. And the way I solved it was by getting into an incubator. All right, it's in the incubator that I met my co-founder. So I kind of solved that first problem. So the other problem is that you need to find actually, so we can think, okay, portfolio optimization, this is a very hard problem, but are you sure that is a problem that people actually have at the bank? So you need to start doing market research. You need to talk to people working at the bank. Is it actually the problem that you have in the bank? What is the dollar amount of this problem, right? How are you currently solving it? So you need to start doing that engagement until you can actually certify that there's what they call a product market fit, that there is indeed a market for the product that you are trying to build, right? So that was the second problem that we solve, and you need to be able to show that what you are building actually is better than whatever is out there. So this is one of the problems you are still facing, because some of the commercial solvers that people are using to solve optimization problems are very expensive. Like Bloomberg is one of has one of the tools people use, and you are in the thousands or tens of thousands of dollars to have subscription to be able to use your optimizer, which we don't have that money, right? So it might be very, very difficult to have those benchmarks, but we were able already to do benchmarks with what is available, like what is the optimizer that are publicly available, and the benchmarks showing of how much our product was better. So that's the other problem that we face. And then the last problem that we face is related to this money. Like, that's the reason why we've been bootstrapping. So if you don't understand what bootstrapping means, it means that you take your own money and you pour into your startup, which is very much showing how much you believe in your idea, how much you believe in your venture. But it's not sustainable. So it's sustainable in the long run, right? At some point, we need to raise funds. So these are some of the challenges that we face, and hopefully some of the ways that we've been kind of pivoting, trying to find solutions and addressing those problems. Hopefully that kind of answers your question.
Yes, thanks. Great.
All right. Thanks. So Gideon wants to leave soon, so let's just have his question quickly.
Okay. Thank you, Obinna. My question is I just wanted to understand what some of the challenges were when you were trying to, navigate from the academia to a startup. And do you have competitions in this field? Because I'm seeing D-Wave is also working on optimization, and there are several companies that are working on optimization problems. So who are your competitors, and do you think you stand a chance?
Oh yeah, of course, we have competitors. If we didn't have competitors, it would have been a bad sign. It means that you're not doing something interesting, right? So you have a lot of competitors, and D-Wave is kind of more on the hardware side of the thing. We have competitors like Multiverse, which is the first quantum software startup to use quantum hardware or quantum-inspired techniques to solve portfolio optimization problems as we are having. We have other startups. Zapata is one of our competitors. We have startups just in the AI field, like Wistful, that are trying to address this problem. We have new startup coming up like iCosta Computing that is having more of a digital and based approach to solving portfolio optimization problem. And there are a lot. Every day I'm kind of learning about new startups in Europe, in Asia, in the States, trying to solve portfolio optimization. So what is our competitive advantage, or what differentiates us from them? So first of all, one of the differentiators is from a business point of view. So a lot of those quantum software startups, they focus on multiple verticals. So they are trying to solve at the same time finance, at the same time logistics, at the same time quantum chemistry, material science. So they are doing a lot of stuff at the same time. And this is very hard, to focus on those different verticals, unless you are a very big company like Google, right? For a startup, it's very hard. So we believe that focus, and even from hearing feedback from investors, having a focus in the specific vertical is very desirable. So this is one of the differentiators from a business point of view. Now, from a technical point of view, like I mentioned, some of the startups, they only focus on the AI, so they don't have the quantum space. Other startups focus on quantum hardware, and they don't have the quantum software piece, nor the AI piece. For those who focus on the hardware, we believe that we have an advantage because the hardware is not yet ready. Plus, it's extremely, how will I put it? It's extremely constrained. I give you an example. There's a problem that we are currently looking at the company that involves you being able to allocate capital that can be at the same time positive and negative, which we call in the jargon long and short position. So to be able to encode that constraint, currently only on quantum hardware is impossible. It's just impossible to model it on the quantum hardware. Whereas for us, it's just a line of Python code, right? So this means that this kind of constraint, they cannot solve it currently. Unless they do something quantum classical, there's no way they can solve it. So we believe, and plus there are a lot of other modifications that you cannot really solve on hardware because you only have 1 qubit gates, 2 qubit gates. When you have all-to-all interaction, it's a total mess on how to encode it. And when you encode it, you acquire like, you need much more qubits to be able to encode all-to-all interactions problems, right? So this means that the size of a real-world problem that they can actually solve on a quantum device is very small, which we don't have, right? So this is how we differentiate. So for us, the more serious competitors are those who use quantum-inspired, mostly based on tensor networks methods. But from a pure theoretical point of view, so tensor network is pretty nice, especially for physicists, because you really have an understanding of what is going on. It's not a black box like neural networks. You have an understanding of how entanglements take scale and stuff like that. But from a representational point of view, there have been works showing that neural networks are more expressive in representing volume state entanglement compared to tensor networks, right? So in that sense, we believe that there's an advantage. Plus, we are using state-of-art generative AI models that are currently revolutionizing the whole AI landscape, especially stuff like transformers, part of the GPT stuff happening. So we believe that already there's business value that has been shown in AI, especially in generative AI, using those very large language model or deep generative model, whereas tensor networks has not yet proven that kind of business value at scale. Right. So this is what kind of differentiates us from companies that use quantum inspired based on tensor networks. I don't know whether that's kind of helping. Plus, on top of it, when we come up with an algorithm, we kind of try to build a moat. So we file patents to protect ourselves and protect ourselves from our direct competitors. Hopefully that kind of answers your question.
Sure. I wish I had more time to really engage with you, but hopefully in the future. I have to log out now to take a class, to give a class.
Sounds good.
All right, thank you.
Oh yeah, sounds good.
Thank you. So please, I think we are really short of time. So just use the chat to ask your questions so it will be fast. And I think Malik had their hand up for a long time. So Malik, go. And so use your chat to ask the questions, Edward and Jonah, so that we can just be fast. So thank you. So Malik, you can ask your question, and if you're still there. If not, maybe we'll just take the question from oh, okay. I think Malik is.
Okay, let's stop sharing. I can see.
All right, maybe you can answer the question in the chat. The question says, excellent work, Estelle. What about your clients? What are the type of your clients and what are their problems that you solve for them? Like, so who are your clients and what problems you solve for them?
Yeah, so as I mentioned before, my clients are financial institutions, bank, insurance, pension funds. It could even be hedge funds. It could be platforms that provide services to retail customers. Like in Canada here, we have something like Wealthsimple, right? So these are kind of our potential clients, and what are the type of problem? So the type of problem that we are solving for them is basically portfolio allocation, portfolio creation, right? So for example, imagine that you have something like a mutual fund. How do you build your mutual fund, or how do you build your ETF, right? So we come up with the algorithm that helps you to build the ETF so that you maximize your return and then you minimize your risk. And how do you allocate your money? So suppose that you want to invest in an index like S&P 500, you are like 500 startups to invest in, but you do not want to invest on all of the 500. So how do you choose the subset of stocks to invest so that you can still perform, maybe outperform the index, but let's say just perform like the index. So algorithm help us to find those stocks. And once you find those stocks, how do you allocate your capital, right? So algorithm help us to allocate the capital. So maybe to mention that the problem of finding the subset of stocks in a large basket of stocks is a factorial problem. And a factorial problem grows way much more than just an exponential problem. It's a very hard problem to find, right? So how many clients we have found out? This is business information we don't share. Sorry.
Yeah, that's fine. Yeah, that's actually business information. Yeah, so thank you. So Jonah, maybe you want your hands it up. Malik, you can use your chat. I don't know, maybe there's a connection problem.
Okay. Yeah. So thanks a lot, Estelle, for your talk. Can you guys hear me?
Yes.
Yes.
Oh, okay. Yeah. So I think that this is just a quick question, also like just on top of like what Gideon asked before he left, particularly about your competitors. For example, JP Morgan just set up like a quantum department that does a lot of financial problems and solve some of those for them. Now, if one is looking more in terms of research, because some of the things you publish, for example, with like the variational neural annealing, one can actually sort of also work in like, because it's a scientific work, one can also like just sort of do a bit of like study on all of this and like just do a proof of principle type of studies on this. And they have like, I could imagine they have like larger data and more problems that maybe might come to them that they can solve. Are these like, are you looking at them like in general, like your possible exit opportunities, or are you like, or are there more like different exit opportunities one can imagine here? Also, can you also make comments about like the time horizons for building like market tractions? Is that like what you're basically kind of like looking forward? Because of course, like VCs are almost VCs are all like interested in market shares, like so they want to see first of all like the market share you're like trying to like target and the market traction before like they do anything, and also the places of exit opportunities, as I mentioned. So yeah, so these are like a couple of questions, because of course, yeah, I just keep it like that. I don't know if my questions are like well ordered and makes sense.
Yeah, sure. So that's a very good point. So one thing I forgot to mention is that one of our potential competitors is actually teams within those big banks like Morgan Stanley and those JP Morgan stuff, especially at the start indeed having this quantum department collaborating with Amazon that has a great quantum solution lab, which is another competitor to us, right? So indeed these are possible ways of exit, being bought by a huge bank or being bought by, I don't know, a huge quantum tech company like Amazon or Google. Those are definitively possibilities. Now, one of the difference, and this is a generic difference that a startup has compared to those very large organizations, is agility. We have the possibility to execute very quickly compared to them. I mean, interacting with large organizations, they are extremely slow to change stuff. They are really, really slow because we need different levels of approval. And by the time you do approval, we have already built stuff, we have already launched on the market, right? So that's the reason why one of their strategies is actually to acquire startups, right? Because it might take a little bit more time for them to build. So for us, it's that agility that kind of differentiates us from the teams within those institutions. Indeed, they are better than us in the sense that they have an infinite amount of funding. they can have an infinite amount of PhDs working for them. So this is also one of the advantage that actually that make competition very fun for us. So one thing that also differentiates us is that since we are at the forefront of research, I kind of look all the time what is happening in the research world. We interact with our colleagues. So I kind of know the research that JP Morgan has been focusing on, right? I look at what they publish. One never knows what they are not publishing, but what they publish, what they file, even as patents, I check the patents and kind of give me an idea of where they are at, right? And they are not close to what I'm doing right now. Other folks are closer, so I have to be more careful. But yeah, the differentiator for us is speed and agility. So now the time scale of raising funds. So nowadays you have to be very careful whom you are raising funds from. Right? We have this last week OpenAI crazy story, kicking one out of the CEO and bring him back. Right? Sam Altman, so you have to be very careful who sits on your board, like whose money is not just money for money's sake. You have to be very careful. And in that sense, you need to know that the investor is there for the long term. So you need to go towards deep tech investors who know that they are not going to have return on the investment in the next 2 years or even 5 years because this technology is not there yet, right? So there are more and more there are these investors coming, and these investors could be okay for you having one client already starting to work with you or 2 clients starting to work with you. They need to see that there's potential for growth, right? For maybe hopefully exponential growth, but they need to see that potential to be able to be there with you and invest while waiting to have maybe return investment in 10 years time. Right. So these are more of the kind of investors that we are looking into. And nowadays, even like banks, they have an investment arms where they invest into startups. And even companies, like recently Microsoft invested in a Canadian company, right? What's the name of that Canadian company again? It's Photonics, yeah, like $100 million. So we have this kind of institutional, very big institutional that invest in these quantum tech startups, right? Because they have researchers in-house who know like the long-term investment gain. So these are probably the kind of investors that we'll be looking at. We don't yet have initial investment. We are looking at some point to that.
Yeah, thank you so much. I think Estelle also has to run. She has really given us a lot of her time, and I think most of the questions have been answered. I see some new ones in the chat, but I think also that's also has been answered. But I don't know if Estelle has time to do that. I'm not so sure of. And I think another great way would be to like reach out to her, I think, and maybe she can comment on ways you can also reach out if you want to. I guess Estelle, are you open for like discussion afterwards? Maybe on do you want to share your email or LinkedIn, or how could people?
So yeah, so LinkedIn, that's probably easier way to connect with me. My email, I don't mind sharing my email. Which email will I share? So many emails. So okay, I might share my company email. So this is my email. For collaboration, I already mentioned I'm not open for collaboration right now. Too busy. At some point, hopefully, but right now, no.
All right. Thank you so much, Estelle. Just to wrap up, we really appreciate your time, and you've actually, I mean, inspired us really with your journey, and I hope we've taken something out of it. So to the general audience, we can still stay connected, and I'll be also following up with an email with the recordings for those who attended, and so keep in touch with us also through LinkedIn, and yeah, so see you next time. So thank you so much, Estelle. Thank you everyone for
Thanks for the
coming. We really
invitation.
appreciate it. All right then.
Bye-bye.
Bye-bye.